Hello, good afternoon students. How are you all? Welcome to the session. This is Suresh, Faculty of Chemistry from Infinity Learn. How are you all? Great, hope you are all doing great. Good afternoon. Well, so today we are going to discuss about a few topics from the chemical kinetics, and the thumbnail it is given as pseudo first order reaction. However, we are going to discuss शुरुआत से discuss करना आज के लिए. So stay tuned. What Infinity Learn is doing for the students who are preparing for NEET examinations. Hi, good afternoon. Welcome to the session. Right. So what Infinity Learn is doing for the students who are preparing for NEET examination. So I just want to give you a benchmark that a few students are there on the board. Good afternoon, Anamani and Ashrita, Akhil Verma, Himadyuti and Satyanarayanan. And these are the achievers from NEET 2024 examination. They are passed out from our Infinity Learn program. Hi Niril, Shivasagar Niril, you are from Bangladesh. Oh, really? So the students who are preparing for NEET examination in India, and also I found many students from abroad also they are joining. A few students is from United Emirates and a few students are from other states also, and all over India and all over across the world the students are joining. Niril, today we are going to discuss about chemical kinetics. Find it here, right? Arshad, you are from Pakistan. Good. Okay, anyways, let's talk about the power of Infinity Learn, the academic program and the power of Infinity Learn. You can see Ashrita got 310 marks in 2023 examination and she got 661 mark in 2024. इतना marks बढ़ गया देखो 351 था क्या? How come she did it? And she just studied the academic program guided by Infinity Learn by Sri Chaitanya. Okay, Queen, Evil Queen, good afternoon. You can see Akhil Verma. So, Akhil Verma, he got 310 marks. इनका 658 marks बढ़ गया. So, 345 marks is the increment. Can you believe it? It is more than a double, right? So, are you ready to crack that kind of result? Yes, just find out. Himadyuti, she got 310 marks and after taking Infinity Learn academic programs, rank achievers programs, she got 652 marks and 342 marks rank badiya. And also you can see Satyanarayanan 330 marks and he got 650 marks in NEET 2024 and there is a 320 marks increment. How come these are all possible? And Infinity Learn has that ability, make it possible, which is imaginary, not possible, right? Yes. Now you can see crack NEET and grab your medical college and grab your medical seat in a reputed medical college. That for you we have ace your test preparation with Infinity Learn, and you have all kinds of courses like boost your course in the NEET examination preparation and everything. You have Infinity Learn Meta app is there, and that Infinity Learn Meta app link is there in the description box. You can just click it on and you can get it that. And also we are also on the social media, and you are on the social media. You can see Infinity Learn YouTube channel. You please like and share and subscribe. We are on the Instagram, Facebook, Telegram, and we have Infinity Learn app also. And one important thing, India's first artificial intelligence driven pathway. So AI driven test prep and course contents are given only from Infinity Learn. Are you ready for that? Okay, so we are done with pathway to academic success, learner's journey with Infinity Learn. So Infinity Learn gives AI pathway to learn and to progress and to test, to clarify your doubts. All are driven by artificial intelligence, right? Now, what I mean to say, just scan your QR code if you have, and without delay, we are going to start about chemical kinetics. Actually, in the chemical kinetics, today's topic of interest is going to be pseudo first order reaction. Of course, it is a pseudo first order reaction. Before going for that, many students are requesting us. We got so many requests online. Sir, शुरुआत से chemical kinetics एक बार दिखाने का पूछ रहे हैं, so that it is a short recapture of the chemical kinetics right from beginning till pseudo first order reaction. That is the agenda for today. So today's class, I can guarantee you that chemical kinetics, definitely you can expect 2 questions from this NEET examination. कम से कम एक question मिलना है. So one question for sure shot, and this chemical kinetics is connected to even in the organic chemistry, SN1, SN2, E1 and E2 kind of things. And there also you are going to get this chemical kinetics in the very important point. And without any delay, you all just take a book and a pen and write along with me. I am going to give a huge concept in a short, in a simplest way, and I can guarantee you that in this session, after this session, you are comfortable to clear the questions and crack the questions from the NEET examination from the chemical kinetics up to the order and molecularity. Are you ready for that? Once everybody give me thumbs up and fire emojis so that we can start the class. Yes, I am from Hyderabad Infinity Learn studio. Okay, you want to come and you can come and we can meet here, right? So what do you learn in today's class? Rate of reaction, factors affecting the rate of reaction, integrated rate laws and analysis of first order reactions, molecularity and elementary reactions, effect of temperature and Arrhenius equation and activation energy. हमारा क्लास में हम ये करना वाला है, ये वाला, and integrated analysis of the first order reaction, and here pseudo first order reaction is also included. Half of the chemical kinetics chapter आज का क्लास सिर्फ आपके लिए. Get ready for that. So what is a chemical kinetics? It's a branch of chemistry which deals with the speed of chemical reactions. Certain reactions go slow, certain reactions go fast, certain reactions are moderate. And I just want to say, classification of chemical reactions based on the reactions. Yeah, Kalpendra, hi, you're late. Good afternoon, Kalpendra. Kapilendra Pangi, you're late. Okay, classification of reactions on the basis of rates. We have classified very fast reactions, the reaction which goes in instantaneous. So example kind of precipitation, job silver nitrate react with sodium chloride is going to give this silver chloride as a precipitate. है ना? And also you have very slow reactions, जैसा आपको rusting of iron, it takes a month, it will take 2 months, 6 months. Okay, Rudrakshi, good afternoon. We just started chemical kinetics. Good afternoon. And also you have reactions that taking place on moderate speeds, just like a hydrolysis of starch, decomposition of hydrogen peroxide, and hydrolysis of ester. These are all comes under this. So chemical kinetics has a scope. Chemical kinetics do not discuss about very fast reactions. Chemical kinetics do not discuss about very slow reactions. Rather, chemical kinetics discuss about the moderate reactions. So their rate is not too slow, not too fast. Okay, let's talk about a rate of a chemical reaction. Rate of a chemical reaction is, otherwise we can say it is a speed of a chemical reactions. In general, for a reaction A gives rise to B. So during a process, concentration of A decreases as time goes on and concentration of B increases as time goes on. So अगर ये rate क्या है? So during a reaction, that there is a change in the concentration with respect to time. So that is what you can say, it's a rate. So I mean to say, a graphical representation, a concentration of A कहाँ हिसाब से concentration of A is decreasing gradually like this. So मान लो अगर time t1 में टाइम t1 में concentration is C1 and टाइम t2 में concentration is going to be C2. ये दोनों का जो अंतर होता है ना, that is the change in the time and this is the change in the concentration, है ना. So ग्राफ दिखाने के स्टाइल सीखो बेटा. And this is the change in the concentration of A and this is the change in the time. So change in the concentration versus time with respect to time is called rate with respect to A. मान लो this is given as a negative. Why it is given as a negative? Rate never be negative, but the negative sign indicates it is a decrease in concentration. Pratibha Yadav, hello, good afternoon. And never and ever assume that rate is a negative. That actually minus जो दिखाई दे रहा है ना आपको, ये मैथमेटिकल ऑपरेटर बिल्कुल है नहीं, है ना, राइट. एंड लेट्स टॉक अबाउट द कॉन्सेंट्रेशन ऑफ बी का हिसाब से. अगर ए इज गिविंग राइज टू बी, सो कॉन्सेंट्रेशन ऑफ बी बढ़ते जाएगा, कॉन्सेंट्रेशन ऑफ बी बढ़ते जाएगा. सो दैट टाइम t1 and time t2 and there is a time gap delta t and it is going to be the concentration and that is the concentration change. So in rate is going to be delta dB by dt and you can say take a tangent here, that is an instantaneous rate. So you have two types of rates. One is a average rate, another one is an instantaneous rate. Average rate is the change in concentration in a stipulated a particular time interval, whereas instantaneous rate is the rate at that instant of time when the time tends to small and average becomes an instantaneous rate. So that's very very important, very important. ठीक है. Now average rate मैं अभी आपको दिया the rate in a particular interval of time. Pratibha, yes, Rudrakshi, hope you are understanding. And this is what you can say, rate average is equal to del A by del T is equal to del B by del T, है ना, right. And also rate average is equal to A2 minus A1 by T2 minus T1. And similarly from the plot B we can function T as a function, we can say B2 minus B1 upon T2 minus T1. How this average rate and instantaneous rate are related? Instantaneous rate can be calculated from average rate in the limit when time change tends to 0 in the limits, and it is represented as rate instantaneous is equal to minus differential A concentration upon differential time is equal to differential B concentration upon differential time. So this is the condition when average rate becomes instantaneous rate. Fine. And let's discuss about so in general reaction, let's say m moles of A plus n moles of B gives rise p moles of C or q moles of D. So what I mean to say, how the rate can be written? The rate can be written as जो ये term आता है ना, that is written as a fraction. So that m become 1 by m, n become 1 by n, p become 1 by p, q become 1 by q. Okay. So that is minus 1 by m dA by dt is equal to minus 1 by n dB by dt, that is equal to plus 1 by p dC by dt, that is equal to plus 1 by q dC d by dt. So in real life you just want to write N2 plus 3H2 and it is going to give rise to NH3. So इसके लिए rate of the reaction can be written as minus differential concentration of nitrogen by dt, that is equal to minus 1 by 3 dH2 by dt, that is a plus 1 by 2 dNH3 by dt. So this everybody can write it. उसमें क्या सिखाने वाले आप? And this is the term मान लो, this is the rate of disappearing of N2, and this is the rate of disappearing of H2. Don't include 1 by 3 in that. And this is the rate of appearance of NH3. समझ में आ रहा है क्या? Right. Very good. Now let us see. So this is the example you can say. So the rate of formation of NO is NOBr, 2NOBr gives rise to NO plus Br2, is found to be 1.6 into 10 power minus 4. एक ही term का है. So it is given as find the rate of overall reaction, the rate of consumption of NOBr. It is given if we have dNO by dt is equal to 1.6 into 10 power minus 4. From there, now the overall rate of the reaction can be written as minus 1 by 2 dNOBr by dt is equal to plus 1 by 2 dNOB by dt plus that is dBr2 by dt, that is equal to 0.8 into 10 power minus 4, and the rate of consumption of NOBr is equal to dNOBr by dt is equal to minus 1.6 into 10 power minus 4. ये minus क्यों दिया? It indicates the rate of disappearance, my dear students. Okay, and units of the rate law. So units of the rate is concentration per time. So the concentration can be mole per liter. The concentration can be pressure. I mean to say the mole per liter second inverse or ATM second inverse for the gaseous reactions. And also factors influencing the rate of a reaction. For the factors that influence the rate of reactions बहुत सारा है. पहला वाला जो concentration of the reactants in case of pressure, in the case of gases, as the rate as the concentration of the reactant or the molarity of the reactant increases, concentration increases, or the pressure increases, concentration increases. Active most I just want to say. Okay, as the pressure increases or concentration increases, rate of reaction definitely it is going to be increased. Also the temperature plays a crucial role. Most of the reactions, if the temperature is doubled, okay, and the rate of the reaction, temperature is increased by 10 units, the rate of the reaction is almost doubled. And a catalyst, so catalyst actually do not involve in the process of a chemical change, but rather it influences to increase as it increases or decreases the rate of a reaction. Mostly catalyst means you assume it is a positive catalyst. 1 minute. Yes. So let us moving ahead. Yeah, rate law. Pratibha, Rudrakshi, Kapilendra Pangi, Evil Queen, Wanganamani. So Nahid, many students are there. You can use short box for two-way interactive session. This is a two-way interactive session. Everybody please follow that. Rate law. What is this rate law? Consider general equation A moles of A, B moles of B gives rise C moles of C and D moles of D. The rate of a chemical reaction is directly proportional to concentration active mass of A to the power X and concentration to the power Y. So what is this X and Y and A and B? That's the important. If you understand, you can understand the maximum level of chemical kinetics. So here A and B, small a and small b, that are included here, that is the numbers that are used. that are numbers that are used to balance the chemical reaction. Rather, here x and y, they are experimentally determined. They are experimentally determined. Okay, so experiment करके निकालना है, and x is said to be the order respective to A and y is said to be the order respective to B. In most of the cases, x can be equal to A and y can be equal to B or may not be equal also. Okay, so x and y may or may not be equal to the stoichiometric coefficients A and B. That makes the sense. So rate law is rate is equal to k a to the power x and b to the power y, and rate we know that change in the concentration, differential change in the concentration upon dt is equal to k a to the power x and b to the power y. So this is known as rate law expression, where k is what you call it as a proportionality constant, and this proportionality constant is nothing but rate constant or specific rate constant, and this specific rate constant can give you how the value of the k can tell you the speed of a reaction. The slower reactions, the k value is very low, the faster reactions, the k value is very fast, right? So like that, Pratibha Yadav, fine. Kapilendra Pangi, I want you to just interact in the class. I want to see you well-being, how you are doing in the class and what you are doing in the class. Everything is accountable. So you are all doing the best for your NEET examination preparing, and मैं आपको कुछ भला करने का कोशिश कर रहा हूँ. आप हमारा इंस्ट्रक्शन के हिसाब से आप अभ्यास करो, आपका भी भला होगा. एंड प्लीज लाइक द सेशंस एंड आपको शेयर करना है आपका फ्रेंड के साथ, एंड प्लीज सब्सक्राइब इट, है ना? आर यू देयर? यू एवरीबॉडी प्लीज गिव मी थम्स अप इन द चैट बॉक्स सो दैट वी कैन go ahead. आगे बढ़ते हैं हमें. So I just want to say the rate law is the expression in which the reaction rate is given in terms of molar concentration, reactants in terms raised to the power by certain numbers, okay, and these which may or may not be equal to the stoichiometric numbers. And very important, the rate law for any reaction cannot be predicted merely by looking at the balanced chemical equation. Every student goes wrong here itself. You just everybody understand the impact of this particular important statement. Okay, now let us talk about, say an example, 2NO plus O2 gives rise to NO2. The rate is given as K NO2 square and O2, but CHCl3 you can say CHCl3 plus Cl2 gives rise CCl4 plus HCl. The rate is given as CHCl3 and Cl2 to the power 1 by 2. So here your game works, here your game does. Hope you understand. Clear? So you cannot write the rate law directly from the balanced chemical equation. Now order of a reaction. What is the order of a reaction? आपका जो rate law दिया गया, जो rate law में powers जो है ना, the sum of the powers is what you call it as order of a reaction. Let's say A moles of A, B moles of B gives rise C moles of C, D moles of D, and this is the rate law. Rate is equal to K A to the power X and B to the power Y. हमारा जो X and Y है ना, and the sum of the X and Y is said to be order of a reaction. X is the order with respect to A, Y is the order with respect to Y, and hence sum of the powers of the concentration of the reactants in the rate law expression is called the order of a chemical reaction. The order can be 0, the order can be 1 or 2 or 3 or any fractional value. Okay, it is purely determined experimentally. Okay, for fraction also, and also units for the rate constant K. Here you जो units है ना, this depends only on this order of a reaction. So we know that rate is equal to K A to the power X, B to the power Y, and k is equal to rate by a to the power x and b to the power y, and x plus y is going to be the order. I just want to say concentration upon time into 1 by concentration to the power n. That is the generic version of the unit constants, unit for the rate constant. And I want to say for the zero order reaction, मान लो बेटा children, for the zero order reaction the rate is going to be mole liter inverse second inverse, mole liter inverse second inverse, and the first order reaction it is going to be a second inverse, and the second order reaction it is going to be mole inverse liter second inverse. Say simply take the order n value 0 and उसमें डालो mole liter inverse second inverse into 1 by mole liter inverse to the power n. So if you take this is 0 and it is going to be mole liter inverse and second inverse, है ना? This is very very important. In this session we are talking about line by line version of the NCERT based. So once every student preparing for the NEET or whatever the competitive examination एक ही सवाल पूछेगा, सर NCERT पढ़ाना है क्या, इतना ही काफ़ी important है सर. Every instructor is going to give you a straight away advice that you need to study NCERT. So when you study NCERT, पढ़ाई करने का तरीका जो होता है ना, you have to go through line by line, उसमें क्या क्या catchy points है, ये catchy points पकड़ के जाना है. प्रतिभा, hope you understand. Kapilendra Pangi and Nirul, good. Who is there from Bangladesh and Pakistan? There are students are coming, nice. And also Annamani is there in the live, so that students, many students, you can ask any kind of doubt in the chat box so that we can have a two-way interaction, right? Talking about integrated rate expressions, फटाफट करके जाना आज. So सारे के सारा order, molecularity, zero order, first order, इसका expressions, graphs, सभी, including your thumbnail shows that pseudo first order reaction we can discuss here. So the zero order reaction, the rate of a reaction is independent on the concentration of the reaction is called as a zero order reaction, where the rate of a reaction is proportional to 0th power of the concentration of the reactant. है ना प्रतिभा? So अगर rate gives reactant R gives rise to product, okay, we can say the rate is equal to d concentration of R by dt is equal to k concentration R to the power 0. So I just want to say rate is equal to k. जो reaction इसमें rate constant का dimension and rate का dimension दोनों बराबर होता है, that reaction is said to be zero order reaction, है ना? Get ready. Now one more, zero order reaction में अगर time versus the rate बदलते हैं नहीं, time universe is stable आता है. Hi, so this is about this zero order reaction. And consider reaction, this is the reactant R gives rise to product. So rate is equal to k R and rate is equal to k, and you can say k into 1. You differentiate this, dr by dt is equal to minus k. So dr is equal to minus k dt. So you can integrate from here 0 to t time, 0 to t time. You can integrate from here 0 to time t, 0 to time t. So I just want to integrated expression. So on integrating both sides, r is equal to minus kt plus I is the integration constant. So you are a medical preparing student. You may not be that good at mathematics, or you may not be like this mathematics, but approaching the physical chemistry in a mathematical way is the best for studying physical chemistry. Mind it. So don't focus on numericals karna. That is not a physics. That is not at all the way to study the physical chemistry. So physical chemistry पढ़ाई करने का वक्त में mathematical approach दिखाना है ना. That is the advice I can give the entire world on the YouTube platform now. Now you can say where I is the integration constant. जब आपका t 0 होता है, जब आपका t 0 होता है, r becomes the r naught, where r naught आपका इनिशियल कॉन्सेंट्रेशन ही होगा. सो जब इनिशियल कॉन्सेंट्रेशन होगा, सो ये वाला आई वैल्यू पकड़ के सॉल्व करना, सब्स्टिट्यूटिंग द इक्वेशन आर नॉट इज इक्वल टू माइनस के इंटू 0 प्लस 1. सो आई जस्ट वांट टू से आर नॉट आई होगा. सो आई वैल्यू आर नॉट का बदल के यहाँ पर आप डालना है. सो दैट सब्स्टिट्यूटिंग द वैल्यू ऑफ I in the equation r is equal to minus kt plus r naught. Okay, so take this kt that side, you are going to get r naught minus r by t. You can say this the same in an understandable way. K is equal to r naught minus r upon t. This is the integrated rate expression for this zero order reaction. So here Pratibha, you can see what is R naught, initial concentration, what is R, concentration of reactant at a time t. Got it? Clear? Fine. Now let us talk about K is equal to R naught minus R by t. You can say in some other books it is said to be Ct minus C naught by t. Okay, so you can take this as R is equal to minus Kt plus R naught, where you can say it appears y is equal to mx plus c. This follows the equation of a straight line, है ना. So that you can have a graph, concentration versus time, you are going to get and you can get a straight line with a negative slope. ये slope आ जाएगा ना minus k का. Like that you study the graphs, you study the graph in that way. Fine. Any doubts? If you have any doubts, you please ask me. Okay, right. Now half-life. The time required to consume half of the reactant is what you call it as a half-life, which is equal to, you can say K is equal to Ct minus C naught by 2. If you take when the time is, when the concentration C naught becomes half, na, the time becomes T half. T half is equal to initial concentration by 2k. K is the rate constant. Initial constant. Raj Singh, hello. Raj Singh, hello. In this way, so what I mean to say, T half is directly proportional to C naught, initial concentration. If you take a graph here, if you take a graph here, if you take a graph here, T naught and initial concentration, you are going to get a straight line passes through the origin, right? PB, hello. Raj Singh, hello. You came late, we are studying the integrated rate expressions. Okay, right? Pratibha, Rudrakshi, Kaplendra Pangi, अभी आए तो you PB, आपका नाम क्या बेटा? सिर्फ PB लिखा. What is your name? Your name is only just written PB. In this T half is given, half life is going to be initial concentration is C naught and it is 2k, है ना. So k is the rate constant, praksha. So constant निकाल के, so I just want to say T half is directly proportional to initial concentration. So T half initial concentration is directly proportional. It is going to be a straight line passes through the origin. Okay, okay. Medini, Praksha, hello. Hope you understand. You see how empathy your teacher is giving when you attend the class, right? So you all attend the class on the regular basis, and description box में आपका मेरा sessions description box में आपको details भी दिया हुआ. Okay, and you all enjoy these sessions for the free of cost, and also in the description box Sri Chaitanya Infinity Learn link is given. You just click it in the Google form so that you are going to get what all updates about the examination preparation updates and everything in the Telegram channel. You are going to get सारा के सारा यही हमारा क्लास का नोट्स PDF में आपको मिलेगा, है ना बेटा? राइट मेदिनी एंड प्रक्षा. आगे बढ़ता हूँ मैं फर्स्ट ऑर्डर के लिए. एग्जाम्पल ऑफ जीरो ऑर्डर, कैन यू जस्ट मेदिनी, कैन यू जस्ट गिव मी एन एग्जाम्पल, वन एग्जाम्पल फॉर जीरो ऑर्डर, वन एग्जाम्पल फॉर जीरो ऑर्डर. अरे कम से कम एक एग्जाम्पल भी दे सकते हैं ना, जल्दी जल्दी. We have the decomposition of any compound on the metals on the surface of the metal is a zero order reaction, and also the thermal decomposition of HI on the gold surface, photochemical reactions bhi aayega. These are all the various examples. You need not have to memorize it, but ye dekhne ke bol sakte hain na, right? So NEET examination, the questions comes in a such a way is a game of the टाइम मैनेजमेंट. सो कैसे टाइम मैनेज कर सकते हैं? हाँ कर सकते हैं. जब आप ये लॉजिक पकड़ के ढूंढना है, ज़्यादा टाइम लगेगा, और सिंपली सर्टेन थिंग्स पढ़ाई करके आपका दिमाग में इंप्रेशन भी हो जाते हैं. सो इफ़ यू आर दैट इंप्रेशन, and 25% of the questions can be answered by looking at that question itself, right? है ना मेदनी, Praksha? That is the best way. That is only possible in the case of botany, zoology, in some cases like chemistry, but not every case in the chemistry. Okay. Who is that? They retract your message. And let us talk about the first order. Could you give me some example for the first order, Sahasra? Come on. First order. So let us talk about a reactant A gives rise to product, and the reactant A gives rise to product. Rate is equal to minus dr by dt. Hi Suresh Kumar, that is equal to kr to the power 1. है ना? So dr by dt kr to the power 1, it is going to be taken as ln r naught is equal to minus kt plus I. Medini, yes, and ln r naught is equal to I is nothing but integration constant. We are talking about integrated rate expressions, and substituting the value of I in the equation. What is I here? Whenever time t is equal to 0, r is equal to r naught. Okay, so it is ln r is equal to minus kt plus ln r naught, and don't say that it is a waste of time taking this equation. This equation you can say indicates y is equal to mx plus c, so that if you draw a graph between y में ln r लेना है, x में time लेना है, you are going to get a straight line again, and you are going to get a straight line that is going to be minus k by 2.303. Like that you need to do. So ln r naught by r naught is equal to minus kt. ये जो expressions आता है ना, ये multiple choice questions में काफ़ी important है. First order reaction का kinetics का है ना? And also k is equal to 1 by t ln r naught by r. So time t1 from the equation, that you can say ln r1 is equal to minus k t1 ln r naught. So that is ln rt, you can say. Okay. Similarly, you can say ln r1 by r2 is equal to k t2 minus t1. So from there you can draw a graph, okay, comparing this equation, that ln r, concentration of the reactant, is equal to minus kt plus ln r naught. So this expression y is equal to mx plus c. So equation of a straight line. I told you physical chemistry you study in a mathematical way. So if we plot ln r against t, we are going to straight line with a slope minus k, and intercept of ln r naught, that is your graph. So, which of the following graph is the first order rate law expression? So, like that you can do it, you know. Yes. Suresh Kumar, how are you? So, you came late? Okay, let us go ahead. The first order rate equation K is equal to 1 by T ln initial concentration upon concentration at time T. Yes, it is there in the NEET examination. Previously, it has been asked for the 0 order and the first order. In 2025 also combinations can be asked. It is very simple, na? So, graphs from the chemical kinetics are very important, and graphs from the ionic equilibrium and electrochemistry is also very important. I am fine, thank you, Suresh. Why you are not coming nowadays? Yeah, Medini, Suresh Kumar, come on. So, try to be in regular. Yeah, let us talk about. So, it can also be ln is equal to 2.303 log to the base 10. So, that k is equal to 2.303 upon t log to the base 10 of r naught by r. You see this particular expression you use for 100 times for solving questions. Kapilendra Pangi, right? Right. Yeah. Problem fever, right? So, whenever you are having kind of problems like fever and all, you just attend the sessions on live. If not, you attend the you see the recordings. Okay, when you see the recordings, you are going to get a doubt, you can put in the chat box or the comment box. Every day I am going to look at this comment box, I can help you out of that. Henam? Fine. So, let us talk about, yeah, that is the one. When you talk about log r naught by r is equal to kt by 2.303. So, log r naught by r upon and versus time is taken, you are going to get a slope k by 2.303. Okay. So, based on this graph you can say the rate, and you can say it is the first order reaction. Hai na? Right. So, Kapilendra Pangi, come on, Suresh Kumar, let us do. So, example of the first order rate. So, hydrogenation of ethane follows first order, and decomposition of hydrogen peroxide, decomposition of N2O5. These are all the basic version of the first order rate of reaction, decomposition of hydrogen peroxide, and half life of the first order reaction. When the half life of the first order reaction is given, k is equal to 2.303 log A naught by A or R naught by R. So, when R naught become R naught by 2, so that T become T half. So, that k is equal to 2.303 T half is equal to log R naught by R by 2, R naught by 2. So, by taking that, k is equal to T half is equal to 2.303 by T log 2, log 2 value 0.3. So, by taking that 0.693 by k milega. So, T half is equal to 0.693 by k. So, this follows the first order kinetics. And Anamani, are you there? Kapilendra Pangi, yes, students facing any issues when you connect with me? So, you can say rate of the first order kinetics is independent on the half life of the first order kinetics is independent on the initial concentration. I just want to say concentration of the reactant and T half. okay, you are going to get a straight line. You are going to get a straight line parallel to the x-axis, parallel to the x-axis. And here, features of first order reaction. A first order reaction must follow this equation. C naught minus x, the value of reactant after time, the value of K can be calculated by different times by using the first order rate law. The first order rate law says phi u, that is the K is equal to 2.303 by T log A naught by A, or A by A minus x, right? And also the time for the half life of first order reaction is independent on initial concentration of the reactant. That's what the graph comes like this, that is T half, and concentration is going to be like this. And also exponential form of this first order rate law is equal to Ct is equal to C naught exponents minus Kt, or you can say RT is equal to R naught exponent minus Kt. So that is R is the concentration of the reactant and at a time t and initial. This is very, very important. And also you can say not, you just take Kt is equal to 2.303 logs A naught by At or a C naught by Ct. It is going to get a straight line with a negative slope, and the slope is going to be minus K by 2.303, and this graph is also important as Suresh Kumar said. Hai na beta? It is there, Suresh. And one more thing you are going to see, log Ct is equal to minus K 2.303 plus log Ct is the equation of line. So, the slope of the line is equal to minus K by 2.303, and y is the intercept. OA is going to be, it is going to be log C naught. Hai na? And so, rate constant of first order reaction can also be calculated by measuring the concentration of the reactant at two time instants, that is initial concentration if not known. This is the analysis of the first order reaction. Analysis of the first order reaction in depth is required for competitive examinations. You are preparing for NEET exam, Suresh, beta? Fine. And also if C1 and C2 are the reactants concentration at two time intervals T1 and T2 respectively, but you don't know initial, but you know between two time intervals. If that is the case, 2.303 log C naught by C is equal to Kt1, also 2.303 log C naught by C2 at Kt2. So, take these two expressions and you can mathematically handle this. Subtracting equation 4 from equation 3, you are going to get 2.303 log C1 by C2 is equal to K T2 minus T1. So, you can calculate this K value is going to be, yes, K value can be evaluated from this. This is an important, very, very, very important, okay, very, very important. Hope you are understanding. So, let us talk about after first half life, the concentration is going to be C naught by 2. Second half life, C naught by 2 square. Third half life, C naught by like that. Ct upon C naught is equal to 1 by 2. Ct upon C naught is equal to 1 by 2 whole square. Similarly, where Ct upon C naught is equal to 1 by T to the power n, where n number of half lives. This particular expression is important for NEET examination. Everybody make a note of it. Everybody please make a note of it. Okay, I asked you to take a pen and a paper and write it and follow these sessions. You are going to get an awesome content by awesome faculties in this Infinity Learn NEET YouTube channel. So, you please join every class and every days. Okay. So, let us talk about the differential rate expression can be integrated for nth order is dc by dt is equal to minus k c to the power n. When it is k c to the power n, n is the order with respect to the reactant. So, provide that all reactants are present in the same molar concentrations. Now, you are doing this for the nth order reactions is given as simplified version. Okay. So, you are going to get rate is equal to 1 upon n minus 1 of 1 by C concentration of that reactant n minus 1 minus 1 by C initial concentration n minus 1 is equal to Kt. That is it. So, this can be useful for any n order reaction. It could be 0, first, second or any kind of, but this is a generic version of the nth order reaction, everybody should understand from here. And also from the T half also you can calculate. Okay, T half is directly proportional to initial concentration 1 by initial concentration n power minus 1. This is one version. Okay, this is one version. Moving ahead, I just want to say order of a reaction and can be calculated based on that particular expression. कैसे calculate कर सकते हैं? T half upon T half 1 by T half 2 is equal to C naught 2 upon C naught 1 power n minus 1, where n is the order of a reaction. So, by taking the logarithm on the either sides, n value is going to be 1 plus log T half 1 by T half 2 upon log initial concentration 2 upon initial concentration 1, and this can help you to calculate the order of the reaction based on the half-life. To calculate the half-life, various methods are there. In that graphical method we discussed, and this is the half-life method. And also let us talk about the pseudo first order reaction. This is actual thumbnail of today's class. Let us talk the hydrolysis of ester. This is your ester. When this ester is hydrolyzed in the water in the presence of an acid catalyst, you are going to get acid and alcohol. In this scenario, the rate of a reaction, you can see the rate of a reaction K CH3COO C2H5 and H2. This is an ester concentration, water concentration. Yes, this is actually a bimolecular reaction. This is actually a bimolecular reaction. Mean to say molecularity is going to be 2. But the thing is, what happens if water is taken in a large excess? So, the concentration of water does not get altered much during the course of the reaction. So, in the rate expression, H2O concentration has no influence when it is taken in the large excess. So, I just want to say the rate of the CH3COO C2H5 and H2O power 0. So, that the new rate is going to be like this, K CH3COO C2H5. So, it is behaving like as a first order reaction. This is behaving like is a first order reaction. So, one more example I just want to say, hydrolysis of sucrose into glucose and fructose. If water is taken in the large excess, the rate of the reaction only depends on the concentration of the glucose. So, I just want to say a bimolecular reaction, if one of the reactant is taken into the large excess, so the rate of the reaction with respect to that is said to be 0, and this bimolecular reaction behave like a unimolecular reaction. That is actually false behavior. That kind of reactions are called as pseudo unimolecular reactions or pseudo first order reactions. This is an example, hydrolysis of an ester and the hydrolysis of the sucrose. Generally, hydrolysis reactions usually follow, I said not every time, usually follows the pseudo order reactions. In this pseudo order reactions, the rate constant is going to be, I'm going to say you, rate constant is going to be always constant as long as the temperature is constant. But here questions can be asked in such a way that if concentration is increased or decreased, रेट कांस्टेंट को किसी नहीं बदलने वाले नहीं है, सिर्फ टेम्परेचर बदल सकते हैं एंड स्टोइकियोमेट्री बदल सकते हैं. दैट्स द रीजन व्हाई यू जस्ट से रेट कांस्टेंट ही होता है. So you never have to change the rate constant. This kind of reactions you see when one of the reactant is taken in the excess, the order with respect to that reactant becomes 0, and finally the behavior of the reaction is going to be first order like behavior. That is what you call it as pseudo first order reaction. So this is how the today we discussed about the rate, instantaneous rate, average rate, and order and molecularity, and zero order reaction, and integrated zero order reaction, and its half life, and first order reaction, and integrated first order reaction, and their graphs and their half lives, and the methods of determining this order of the reaction, graphical methods we have seen, and half life method also we have seen. And finally, we have seen up to pseudo first order reaction, right? So hope you all enjoyed today's class, and अगले class को मिलेगा आपको Arrhenius equation and activation energy and various mathematical expressions for that. So my dear children, hope you enjoyed today's class and you all like the session, and share with your friends. इन लोगों को भी फायदा होना चाहिए, and you please subscribe to this NEET channel. Okay, thank you very much. Yeah, Himesh, fine, thank you Himesh. So फिर मिलेंगे अगले क्लास में ज़्यादा कंटेक्स्ट के बाद. Okay, thank you. Signing off, Suresh, Faculty of Chemistry from Infinity Learn. See you. Follow this channel and please like and share this lecture. Okay, thank you very much. God, bye.